Hi, my name is Katie Sue, and I'm going to be explaining Calc BC FRQ from pages 87 to 89. The first question involves using the polar coordinate and the polar function. Part A asks us to find the rate of change of x coordinate with respect to theta at the point P. And when we're finding the rate of change of the x coordinate, we have to use this formula x equals r cosine theta. And for y, we have to use r sine theta, but we don't need this for this part. So for x equals r cosine theta, we plug in 3 theta times sine theta times cosine theta, because for r, we can plug in this function right over here and times our cosine theta. And this is when theta equals pi over 2. So when theta equals pi over 2, I calculated it and I got negative 4.712 as the answer. And for part B, it's asking us to find the area of region between the inner and the outer loops of the graph. So for this one, the smaller loop has the interval from 0 to pi, and the larger one has the interval from pi to 2 pi. So in order to find the area, the general formula for this is 1/2 interval of the whole r squared d theta. And in order to find the radius r, we can find that we have to use different functions from pi to 2 theta and from 0 to theta. So I did 1/2 times the integral from pi to 2 pi times r theta squared d theta minus 1/2 times integral of 0 to pi of r theta squared d theta. And after calculating this, I got 139.528. And part C asks us to find the value of theta that gives the point on the graph that is farthest from the origin, so 0.00. And we have to use this dr over d theta function. So I use this function right over here, 3 sine theta plus 3 theta cosine theta, and I set it equal to 0 because whenever we're trying to find the farthest point from the origin, we have to set it equal to 0 and to find the points where it makes it equal to 0 and compare the values. So it equals 0 when theta equals 2.03 and when theta equals 4.91. So I plugged in values 2.028 and 4.91, and the reason I include 2 and 2 pi is because it is the interval from 0 to 2 pi. And when theta equals 4.913, it had the largest value of negative 14.4 as the distance. So therefore, when theta equals 4.913, it gives the point on the graph that is farthest from the origin. Number 2 asks us to find the limit of the function they gave us. So the function they gave us was fx equals x e to the negative 2x, and when x is equal or greater than 0. And the first part A asks us to find the limit of f of x. So in order to find the limit, I did limit of when x goes to infinity, x e to the negative 2x, and it became x over e to the 2x. And when we find the limit of this function, it becomes 0 because e to the 2x is way much greater than the x. And for part B, it asks us to find the maximum value for x when x is greater than or equal to 0 and justify your answer. So for part B, I found the f prime of x in order to find the maximum value. So for f prime of x, I did e to the negative 2x plus x times negative e to the 2e to the negative 2x. And for this, I got when f prime of x equals 0, it gives us the maximum or the minimum value. So I got 0 and x equals 1/2 when f prime of x is 0. So for the maximum value, I plugged in 1/2 to the function and got 1/2 e to the negative 2 times 1 over 2. Therefore, I got 1 over 2 times e as the maximum value. And for part C, it asks us to evaluate integral from 0 to infinity of f of x and show that the integral diverges. So in order to show the integral diverges, I used the use of to find the answer for this one. So for this one, I set u equals x, so du is dx, and dv is e to the negative 2x dx, and v equals negative 1/2 e to the negative 2x. So for this one, I found the u and found du, and for this one, I found the v by finding the integral of dv. So for this, I have to find out integral from 0 to b of x e to the negative 2x dx. And for this, I got negative e to the negative 2x times negative x over 2 plus 1 over 4, and the interval is from 0 to b. And for the next part, I found integral from 0 to infinity of x of e to the negative 2x dx times 2x, because I used these two dv and b. And I got limit of b, when b goes to infinity, the limit is negative 1/2 times b over 2 plus 1 over 4. And I got negative 1 times 1/4, which I got negative 1/4. For number 3, I used a separate piece of paper because there was not much space. So the question asked us to find the interval of convergence of the power series for f and show the work. So for part A, I used this function, and I found a pattern and got x minus 2 to the n plus 1 over 3n plus 1 times n plus 2. Because for power series, you have to find the second term. So I did n plus 1, and n plus 1 plus 1 is n plus 2. And found times in reciprocal of this function, because you're supposed to divide the second value from the first original value. So what I got was n plus 1 over n plus 2 times x minus 2 over 3. And you have to find the limit when n goes to infinity. And I was able to simplify this down to 1/3 times absolute value of x minus 2. And in order for it to converge, it has to be less than 1. So I had to find an interval, which made it from negative 1 to 5. And in order to check the interval convergence, you have to check the endpoints as well, if it converges or diverges. Because if it diverges, you cannot include the endpoint as equal or less than. So when I checked negative 1, it gave a alternating harmonic series. So for this one, it converges conditionally, so we could include negative 1 as the endpoint. However, for x equals 5, I got 1 plus 1/2 plus 1/3, which shows it diverges. So I couldn't include this as the final interval. And for part B, it asks us to find f double prime of 2. So we have to find double prime of this function and plug in 2 to the function. So when I find f double prime of 2, I got f double prime of 2 over 2 factorial, and it equals 1 over 3 squared times 3. So f double prime of 2 equals 2 over 27. And for this one, we have to use the alternating series error bound to show that approximation differs from f1 by less than 1 over 100. So when you're finding the alternating series error bound, you have to find the next term value. So for this one, since it gives us onto the 3rd degree power, we have to find the 4th value. So for C, I did f1 equals 1 plus 1 minus 2 over 3 times 2 plus 1 minus 2 squared over 3 squared times 3. So I was able to get 47 over 59. In order to find the error bound, we have to find the first term. So I did f of 1 minus 47 over 54 has to be less than 1 minus 2 cubed over 3 to the 3 power times 4. So it's 1 over 108. So this shows that this is less than 1 over 100. So I was able to prove that approximation differs from f of 1 by less than 1 over 100. Thank you for listening.